Hello, chemistry students. This is your teaching video for ChemQuest 35, the Intro to Chemical Reactions. And it starts with some review, which is a good review. This is a review back to Chapter 6, where you learned how to write chemical formulas. So, write formulas for the following compounds. Remember, our first question as we write formulas is whether the compound is ionic or molecular. We know something is ionic because it's made of a metal and a nonmetal, or it has a polyatomic ion in it. We know that something is, sorry about that, the noise of this computer sometimes is a little annoying. There we go. Okay. We know a compound is molecular if it's made of two nonmetals. Okay. Then remember, when we're writing the formulas for ionic, we have those 4 steps: the symbols, charges, crisscross, lowest whole number ratio. And for molecular, the prefixes equal the subscripts. So, this first one, dinitrogen pentoxide, right? Here's nitrogen, here's oxygen. They're both nonmetals. So, dinitrogen pentoxide is a molecular compound. So, my prefixes become my subscripts. So, my symbol for nitrogen is N. Di, remember, this is on our helper sheet. You don't have to have this memorized, right? So, you want to have your helper sheet handy. Di is 2. Oxide is oxygen, and pent is 5, so it's N2O5. Letter B, calcium phosphide. Again, question is if this is ionic or molecular. And again, calcium, right, is a metal, so I automatically know that this is a ionic compound. So I'm going to do my symbols, charges, crisscross, lowest whole number ratio. My symbol for calcium is Ca. It's in group 2A, which means it has 2 valence electrons it loses, so it gets a +2 charge. Phosphide. Remember, the IDE ending means a single atom, so that's phosphorus. And phosphorus is in group 5A, which means it has 5 valence electrons, so it's going to gain 3, so it has a -3 charge. So then I crisscross down. Remember, just the numbers themselves, not the charges. And then symbols, charges, crisscross, lowest whole number ratio. 3:2 is the lowest whole number ratio. Letter C, copper 2 phosphate. Again, copper is a metal. Okay. So this is copper. This is an ionic compound. So my symbol is Cu. Remember, when I have this Roman numeral, that's telling me the charge on copper. So it's +2. Phosphate, ATE ending, means it's a polyatomic ion. It's one of the ones you should have memorized. So it's PO4 with a charge of -3. So then I crisscross down. So my 3. Now, again, I have phosphate here, so I have to use parentheses and a 2. And a 3 and a 2 is the lowest whole number ratio. Lithium sulfate. Again, ATE ending tells me it's a polyatomic ion. Lithium also is a metal. So again, that's going to be an ionic compound. So my symbol is Li. Its charge is +1 because it's in group 1A, so it loses that 1 valence electron. Sulfate that you have memorized is SO4 with a charge of -2. I crisscross down, and I don't need parentheses this time because I just need 1 sulfate. To write the names, right? So naming for molecular compounds, we still have to ask if it's molecular or ionic. Molecular, again, our prefixes just become our subscripts just become our prefixes. And remember, our second element ends in "ide." Okay, for molecular. For ionic, basically, we're going to combine the name of the cation and the anion. So, again, I have calcium Ca, which is a metal. So that tells me right away that it is an ionic compound. So then remember I have to ask about my metal if it's in a tall column or short column, because I might have to name it twice if it has more than one possible charge. Calcium's in a tall column, so I won't have to worry about that. So that is just calcium. Cn, that is a polyatomic ion that I don't have memorized, so I look for Cn, and it's right here, and it's cyanide. So it's calcium cyanide is the name of that. Letter B, P2O3. Okay, again, phosphorus, oxygen, nonmetals. So my prefixes or my subscripts become prefixes. So 2 is di, so this is diphosphorus. 3 is tri, and then oxide, because my second element ends in I. All right, FeCO3. Well, hopefully you recognize CO3. That's a polyatomic ion you have memorized. So then I need to look, so I know it's ionic, so I'm looking at my periodic table for iron, and iron's here, which means it's in a short column. So then I have to remember, check my helper sheet. Is iron on my helper sheet? Iron is on my helper sheet. It has more than one possible charge. So I have to figure out what charge this iron has. Remember to do that, I'm going to look at my CO3. CO3, I have memorized, has a polyatomic charge of -2, and there's just one of it. So this iron has to have a +2 charge. So the easier way to name this, you're going to have to name this twice, is to use the Roman numerals. Remember, the Roman numerals equal to the charge on the iron, and then this is carbonate. Then again, I use my helper sheet, right? Iron, there's a +2, +3. We said this was the +2, that's the lower, so it's fair. And remember, the two endings here are us and ic. And this is the lower charged, and this is the higher. So the +2 is the lower, so this is going to be ferrous carbonate, and I do want you to name it twice. Okay. K3N. K is a metal, that's potassium, so I know it's an ionic compound, but potassium's in a tall column, so I don't have to worry about naming it twice. So this is just potassium. And N is nitrogen, and when it becomes an ion, it's nitride. So this is potassium nitride. All right, chemical reactions, what they look like. Here's what a chemical reaction looks like when it is written. There is a sentence that you can write to describe what happens above. Copper 2 nitrate reacts with zinc metal and yields zinc nitrate and copper metal. Take a minute to notice the relationship between the sentence and the symbols in the reaction. Now try a few yourself. So what they mean is, notice and yields is my arrow. Reacts with is my plus sign. And then this and here is this plus sign. Okay? So, number 3, given the following reaction, write a sentence that goes along with it. So I first have to name this compound, and again, this is a metal, so this is an ionic compound. Calcium's in a tall column, so I only have to name it once, so this is calcium chloride. The plus sign, remember, becomes reacts with. Again, here's a polyatomic ion I have memorized, so it's an ionic compound. Silver is in the short columns, but when you look at your helper sheet for silver, silver only has one possible charge. So remember, I only name it once, and I just call it silver nitrate. And yields, oops, not any yields. Okay, I just sometimes just do yields for that, okay? And again, ionic compounds, so that's calcium nitrate, okay? Because calcium's a tall column, only one name. And that's what the plus sign becomes. And then again, silver, only one possible charge, so this is silver chloride. Given the following sentence, use chemical symbols to write a reaction that represents it. So nickel 2 nitrate, that's an ionic compound. So nickel is Ni. 2 tells me the charge on nickel. Nitrate you have memorized as NO3, -1. I crisscross down, and I'm going to need parentheses for my 2. Reacts with becomes a plus. Sodium carbonate. Again, carbonate, polyatomic ion you have memorized. So symbol for sodium is Na. Its charge is +1. Carbonate is CO3, -1. So nothing to do because I crisscross down ones and reduce. And yields becomes my arrow. Nickel 2, Ni +2. Carbonate, CO3. Okay. Carbonate, I made a mistake here. Carbonate has a charge of -2. So I do need to crisscross down here, so I have Na2CO3. Sorry about that. +2, -2, so I could crisscross them down, but I would reduce them then, so I don't need to do that. And is plus. Sodium is Na, charge is +1. Nitrate is NO3, charge is -1. Given the following reaction, write the sentence that goes along with it. So again, this time we are putting it into a sentence. So again, this first compound is ionic. Carbonate's one of our polyatomic ions we have memorized. So this is sodium carbonate. And again, I don't have to do anything more with like Roman numerals or anything with sodium because it's in a tall column of the periodic table. The pluses reacts with. Aluminum and chlorine, though it's a metal and a non-metal. Aluminum's in a tall column, so only one possible name. So this is just aluminum chloride. To yield or yielding, okay, whatever you want to do. Metal, non-metal, so it's an ionic compound. Sodium's in a tall column, only one name, so sodium chloride. The plus sign is an and. Again, aluminum, metal, carbonate, polyatomic ion, so it's an ionic compound. Aluminum's in a tall column, only one possible charge. So this is aluminum carbonate. Write an equation to go along with the following sentence. So lithium reacts with water to produce lithium hydroxide and hydrogen. Lithium, so it is reacting all by itself. Reacts with is my plus sign. Water we know to be H2O. To produce is our arrow. Lithium hydroxide, that's a compound. Hydroxide is one of the polyatomic ions you have memorized, so this is an ionic compound. So my symbol for lithium is Li. Hydroxide is OH, -1. I have +1, -1. I would crisscross down and they'd reduce, so I just leave it LiOH plus hydrogen. Now, I do have to be a little bit careful about hydrogen. This is why you have those diatomic molecules memorized. Because hydrogen, even when it exists all by itself, is always diatomic, so it's going to be H2. Introduction to reactions. During a chemical reaction, new substances are formed. Reactants are transformed into different products. Atoms are never created or destroyed, but they are rearranged. A chemical equation represents what happens during a reaction. The following is an example of a chemical reaction. So example equation, Ca plus HNO3 yields CaNO3 in parentheses 2 plus H2. This equation describes the reaction of calcium with nitric acid to produce calcium nitrate and hydrogen gas. You may notice that there are more total atoms on the right side than there are on the left side of the equation. If this seems strange to you, don't worry about it now. We'll fix this later. Note, in the above equation, the hydrogen gas is written as H2 and not simply as H. There are a few elements that exist as diatomic molecules. If a substance is diatomic, then the substance must always be bonded to something. A hydrogen atom is diatomic, and so it must be bonded to something else, like in hydrogen chloride or hydrogen nitrate. If nothing is available for it to bond to, it will bond to itself by forming H2. All of the diatomic substances are listed below. So this is that Brinkelhoff that you have memorized, right? Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. When by themselves, these elements exist as Br2, I2, N2, Cl2, H2, O2, F2. Okay. By the way, on your polyatomic ion quizzes, this is how they should be written. By the way, you can remember these by recalling a made-up name, Mr. Brinkelhoff. Consider the bromine atoms in this reaction. Why is bromine written as Br2 on the right side? Because of this, right? So that's because bromine is diatomic. Okay, so it has to exist bonded to something, so it bonds to itself. The correct formula for lithium bromide is LiBr. Why doesn't bromine need a 2 in this formula? Lithium bromide, right? It's a metal and a nonmetal. That's an ionic compound, so to get the formula, it's Li, charge of +1, symbols charges, crisscross, which are 1 and 1, and so I have LiBr. So why doesn't bromine need a 2 in this formula? Because how many bromines is determined by the number of lithium. And because lithium only has a charge of +1, okay, I'm only going to have 1 bromine here. The person who wrote your ChemQuest explained it this way. Lithium ion and bromide bond together as lithium bromide so that the overall charge of the compound is neutral. Right? If we had 2 bromines with a -1 charge, we'd have a -2 charge, which wouldn't balance out the +1 charge of lithium. Name the reactants from the reaction in question 7. So remember, reactants are on the left and the products are on the right. So naming these reactants, again, this is lithium bromide and phosphorus. All right, single replacement reactions. There are several types of reactions that follow predictable patterns. The first kind is called a single replacement reaction. See if you can figure out the pattern in each of the following reactions. So again, you're going to kind of look at these carefully and try to see if you can find something that's consistently happening in them. Answer the questions that followed based on this chemical reaction. So let's look at this a little bit more. Silver is a metal. Potassium is a metal. Chlorine is a nonmetal. My product, I have a metal. Notice it's a different metal, a metal, and a nonmetal. Look at this one, right? Metal, nonmetal, metal, metal, nonmetal, metal. Right? So here I have a metal reacting with a compound. And when it does so, it takes the place of the metal, right? That metal is kind of displaced and all by itself, and now silver's in the compound. So letter A, why can't NaMg be produced? Okay, consider the charges of the sodium and magnesium ions, right? This is my positively charged ion. Would be a positively charged ion. Magnesium would have a positive charge. Chlorine has a negative, right? Remember, metals tend to get a positive charge. Non-metals tend to get a negative charge. This is a positive, negative, positive. So why can't sodium, magnesium be produced? What would I be putting together then? 2 like charges, okay? So the person who wrote this said that sodium ion cannot bond with magnesium ion because they are both positive. So you can't put two ions with the same charge together in a compound. All right, B, why can't NaCl2 be produced? This is an ionic compound, right? So how do I get my formula for an ionic compound? I do my symbols, I do my charges, I crisscross. So again, it has to be NaCl. If I had NaCl2, Cl has a charge of -1. That would give me a total charge of -2. Sodium has a charge of +1. This wouldn't be neutral. And remember, one of the rules for ionic compounds is that they have to be neutral overall. Your total positive charge has to equal your total negative charge in an ionic compound. Okay? So again, the person who wrote this said, sodium ion only requires one chloride. Sodium NaCl2 is not a neutral compound. Given your answers to parts A and B, do you think that NaCl and Mg are the only products that can be produced? So what they're saying is there some other way to combine these three to produce something different? Okay. And yes, they are the only products that can be produced. Number 10, given the following reaction, okay, so again, lithium is a metal, it has a positive charge. Calcium is a metal, it has a positive charge. Phosphate is a polyatomic ion that has a negative charge. Lithium has a positive, phosphate has a negative, calcium has a positive charge. So why can't CaLi2 be produced? Right? Because again, we can't put two ions with the same charge together in a compound. Again, the person who wrote this said calcium ion and lithium ion won't bond because they are both positive. Why can't Li3P be produced? Well, notice here, what do I have? I have a phosphate that has oxygen in it. If I just produce this, what happened to the oxygen? Okay, so why can't Li3 be produced? Because we can't destroy oxygen. We can't destroy atoms, okay? So there's only this phosphate, okay, as a reactant, and so we need phosphate as a product. The person who wrote this said, although lithium phosphide is neutral, there is no P-3 in their equation. There is only phosphate, and we will almost never be breaking up polyatomic ions like phosphate. Don't mess with polyatomic ions. So are lithium phosphate and calcium the only substances that can be produced? Yep. All right, write chemical equations for the following reactions. Aluminum sulfate, so that's an ionic compound. So my symbol for aluminum is Al, its charge is +3, using my periodic table. Sulfate is SO4, you have memorized with a charge of -2. I crisscross, and I'm going to need parentheses. Reacts with becomes a plus. Barium, that's Ba, and it's not bonded to anything. To produce is by arrow. Barium sulfate, that's an ionic compound. My symbol for barium is Ba, its charge is +2. Sulfate is SO4 that you have memorized with a charge of -2. I could crisscross down these 2's, but then I would end up reducing them. So I'm just going to leave it the way it is. And is my plus sign, and aluminum is Al. Magnesium, Mg, reacts with plus copper 1 nitrate, that's ionic. My symbol is copper, charge of +1. That's what the Roman numeral is telling me. Nitrate you have memorized as NO3, -1. So again, I'm crisscrossing down ones to produce magnesium nitrate. Again, that's an ionic compound. So my symbol for magnesium is Mg. It has a charge of +2. Nitrate's NO3, charge of -1. I crisscross down. I'm going to need parentheses here and a 2. And is my plus, and copper is Cu. Sodium Na reacts with plus calcium phosphide ionic compound. Calcium symbol and charge, and phosphide is a single atom, the IDE ending with a charge of -3. So this is Ca3P2. To produce is my arrow. Sodium phosphide. Again, ionic compound. Sodium is Na, charge of +1. Phosphide is P with a charge of -3, so this is Na3P. And is my plus, calcium is a Ca. Okay. Phosphorus, that's P. Reacts with is a plus. Sodium chloride, that's an ionic compound. Na plus, Cl minus, nothing to crisscross to produce because they're both ones. Sodium phosphide, ionic compound, Na plus, P -3, so Na3P plus. Now chlorine I have to be a little bit careful about, right? Because chlorine's part of Hofbrinkel, so it's going to be Cl2. Each of the reactions you wrote in question 11 follows a similar pattern. The same pattern followed by all of the equations in this section describe this pattern, right? In all of these, notice, right, I have an element reacting with a compound, 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 an element reacting with a compound. Also notice for my products, element compound, element compound, element compound, element compound, element compound. This is technically considered an element and a compound. So how do you want to describe that pattern? Well, it's kind of up to you a little bit of how you want to describe that. Okay. But we always have a single atom that reacts with a compound. And the atom replaces the element that it's like in the compound to produce a different element and compound. Right? Sodium is a metal, so it takes the place of calcium that's the metal. Phosphorus is a nonmetal, so it takes the place of the chlorine in the compound. So question 13 asks us to complete the following reaction. So based on that idea, right? Silver, this is a metal. So it's going to take the place of the metal in this compound, which is sodium. So all by itself is going to be sodium. And then I'm going to have the compound with silver and chloride, which is ionic. Silver only has one possible charge. Chloride's -1, so it's just Na plus AgCl. All right, rubidium. Again, this is a metal. So it's going to take the place of the metal in this compound, which is aluminum. So all by itself is going to be aluminum. It gets pushed out of the way. And I'm going to have rubidium oxide. Again, it's an ionic compound. Rubidium is in group 1A, so it's a charge of +1. Oxygen is in group 6A, has a charge of -2. So Rb2O and aluminum. Lithium is a metal. So it's going to take the place of the metal, which is calcium. So calcium's all by itself, and lithium, this is an ionic compound, and phosphate is PO4 with a charge of -3, so Li3PO4. It doesn't matter what order you write these in. Your reactants or products are in. So if you were struggling with that, I hope that video helps. Have a great day. I will talk to you tomorrow.